Hey, Nicholas.
Hi there, how are you?
I'm good. How are you?
Excellent, thank you.
I see the website is coming along. Thank you so much for that work.
Oh, no worries. Yeah, we're trying to basically automate the creation of the pages now. Because right now it's just the markdown stuff, but we need to automate that with GitHub Actions on the same way they do it for the gateway.
Got it.
Still a bunch of stuff actually to write down in there for the documentation. So
Yeah, but I think you set us off a really good start.
well, thanks to Laura as well.
Right.
Hey, people.
Hello, hello.
How's it going?
Pretty good. How are you?
Pretty good. I did hear that I wanted to say that Jeremy said he would be late, and then I don't know about Paul yet, so let's give them a few minutes. Tuesday, you know?
Yup.
Yeah, another Tuesday.
Happy Tuesday.
Yeah, a Merry Tuesday to everyone.
But it's the end of February already. Can you believe it? It's like time really flies.
I know,
Um,
I'm shocked.
Over here on the East Coast Mid-Atlantic US, we haven't even had winter yet. And it
Oh,
doesn't look
really?
like we're going to. Yeah, pretty much not a single inch of snow. And I've been looking enviously at the
People snow
mountains in the
pics.
Southwest and Pacific Northwest that have been getting dumped on.
Yeah. Yeah, I heard for the PNW some more snow is coming this week, so it felt pretty spring-like. The birds were all chirping and such, but
Our
we're
cherry blossoms are blooming in DC already.
oh wow. Yeah. Yeah, I think some like really early looking cherry blossoms were blooming here too. But hopefully they're not like the main group because I haven't gotten my spring act together to enjoy this. But all right, let me just message Paul real quick. But otherwise we can get started in a little bit. Okay. Okay. Paul can't stick around too long because he has a conflict, but he's gonna come help us for a second, make sure we have some screen share, and then we can go through the agenda together. So
Thank you
let's give
all.
it, yeah, let's give it like 2 more minutes so he can drop by and get us organized. Internet powerful.
Or it says host participant disabled screen sharing.
Yeah. I see
I'm
host
logged
disabled.
in.
I see host disabled participant screen sharing.
How odd.
Mhm.
Who's the host?
I was the first to join. Let me exit and come back in.
Is that how that
Mike.
works? Under participants.
Like I should be the
Oh,
host.
I can claim host. What happens if I'm pressing it?
press
Oh,
it.
I have to enter a host
You need a
key.
key.
Oh, I can't. I don't know the host key. But yeah, I see under the participants
For some
window, someone
reason-
can claim host. I don't know why your account didn't auto claim host.
Oh, let's see.
You know
Yes,
mean?
I know. Claim host. Host key. What on? I am the host. I don't need the key.
Right. We all
The
recognize
key
you.
is me. I am the host. All right, let me see if I can enter. I must need to like re-enter credentials or something.
Right. So secure. So secure we can't use any of the features.
Check my email. Okay.
Okay.
How many engineers does it take to share the screen? Claim host. Okay. Now that's just not doing anything. Love it. All right, let me try
Okay.
rejoining this.
Okay, thanks for helping us. Our Zoom powers are limited. There you go. Now you're the host.
All right, you got screen share. Have fun.
Okay, I
See
see it.
everybody.
Thank you. Okay,
Thank you, Paul.
let me share this. Here we go. Okay. After all of that, welcome to SIG Multicluster. This is the meeting of Tuesday, February 21st, 2023. Our agenda begins with a four-part barbershop quartet. So Mike, Deds, Jay, and Packer, you can take the floor to discuss the community doc. You can share the screen if you want also.
Mike, I know you contribute to the multi-cluster controller. but do you want me to go first with the first 3 topics?
Please take the lead.
Okay, Laura, could you unshare? Because they say you
Yes.
cannot start share. Okay.
Oh, I see. Okay. Yep, go for it.
Can you guys see my screen?
Yes, I see the community doc.
So, okay, I'm gonna get started then. So there have been some interest from the community about some of the topics such as cluster inventory, multi-cluster control plane, multi-cluster controller, and the work API. And we basically started this talk to mostly trying to gather some interest and have some feedback. So please feel free to interrupt during this presentation and provide your comments or any feedback or any suggestion. Because nothing here is like, this is the way we should do it. This is mostly just a brainstorm idea documents. So before I get started, the concepts, I want to highlight this point that Mike wants me to highlight. The concept of the APIs here obviously should reside in a Kubernetes cluster, but it doesn't have to. It can be in an RPC server or a cloud API provider. But for simplicity of the discussion and the demo, I'm gonna assume that we're gonna be working with a Kubernetes cluster. And just want to quickly mention the topics below are vendor and provider neutral. So nothing that is specific to a certain vendor or provider. Okay, so the first topic I want to discuss is cluster inventory. We all have a certain, in order to deal with multi-cluster, we probably all are quite somewhat familiar with the concept of cluster inventory or cluster registry. Basically, it provides you a list of clusters for you to manage, and then each of the clusters have a unique slot in the inventory, so that you can maybe manage it or see some status, or just know that, hey, these are the clusters that I am managing. So the reason I want to go first with this cluster inventory topic is in thanks to the work that Laura and the community, the cluster ID proposal in the KEP 2149 has been agreed upon, and there's the implementation is actually now in the About API. So in the About API, you can define a cluster properly with the cluster ID with a certain value. This value can be the name, or it can be a unique identifier as well. And then we also have the concept of cluster set. So I feel like with this really great work from Laura and the community, having this sort of a backbone of uniquely identifying a cluster, I'm hoping that we can come up with some idea of building on top of that, so we can expand the usage to having a cluster inventory. So having that cluster inventory, what is the use case, right? So again, it gives you kind of a centralized location to view or maybe manage multiple clusters, and then it allows you to maybe add or remove clusters that you want to track through some kind of registration or approval process. And then it potentially, having a set of cluster allows you to do some work on it, such as the KubeSig project work API. It also provides sort of a foundation work for building a multi-cluster control plane, because without the inventory, you don't know what you're working with in a multi-cluster. And I got feedback from the community to also mention specifically the GitOps. So GitOps, without going too deep into it, GitOps is using Git as a single source of truth for Kubernetes resource manifest deployment. So having a standard protocol of cluster inventory could help the GitOps tool to link those resource manifests directly to the cluster that you want to apply to. So I'm going to take a pause here and see if there are any feedback. Hoping to hear some from you, Laura, because
Yeah. So yeah, a couple things I'm thinking about, but one is So one nice thing about the About API is that it's this cluster local representation of these two pieces of information without itself specifying that it's a cluster registry. You know, like it's the piece in between it is the cluster local piece. This kind of, like, I don't have the like previous context in it, but I know that a cluster registry was like a big project that SIG-MC tried to solve a couple years ago that was kind of like dropped in favor again, it kind of is before me, but dropped in favor of I think at the time there wasn't enough like known use cases about like what that cluster registry would what would be using that information besides like, oh, generally we know that something should know about all of them. So I think it ended up being hard for the community at that time to specify what that was. And then now to date, especially in terms of MCS, some sort of MCS controller that knows something like what a cluster registry would need to know is required, but not specified. I mean, speaking for GKE, there's an out of cluster process to know who is a member of the cluster set. I think for Submariner, it's in cluster in a central, more like a hub cluster. Though Stephen can totally fix me if I said that wrong. So those have now like evolved a little bit like past, or they've evolved past where this conversation was in the first place because they have actual usage. So I do think that's a good opportunity to, re-talk about it. As to whether it's an extension, I guess, of the About API, the way I guess I imagined it is that something has to populate what's in cluster property and like be the admission controller for that information. And right now it's very like vague what would be that, and a cluster registry could be that. But since we haven't defined that concept almost on purpose, then yeah, I feel like that's kind of like the state. I think a potential good step or something that falls naturally out of the like centralness, I guess, of like About API as a SIG-MC project is that like right now, all that we really say is that users of MCS API must populate About API so that MCS can make DNS. And then on top of everything, DNS in the MCS API spec is optional, but I don't think it is in practice in all of our cases. So yeah, I think just in general, I want to bring up the point that like there's not a strong standards obligation between the three of these things as it stands right now. And I do think if we try to standardize what a cluster registry is and how tooling should like interact with About API or through a cluster registry concept that maybe it self-populates the cluster local representation, which happens to be About API. That would like tie them together a bit more strongly. And maybe the time is for that since we have some real examples. Okay, so that was a bunch of thoughts that just came out of my brain, but.
No, I think that makes a lot of sense. I was hoping we reach to somewhat, maybe not a conclusion, at least having the starting discussion point of maybe we can start standardizing the cluster registry again, or having the attempt, like you say, maybe with some linkage to the About API. So I quite like that discussion point. Does anyone else have any comments on this topic?
We can get into it more later, but yeah, I tried to touch on exactly what Laura was describing in the first sentence or two of the multi-cluster controller section at the bottom. Basically that it may implement a multi-cluster controller may implement or be dependent upon some other implementation providing the like cluster registry, fill out the cluster ID kind of thing. I think it's
Right,
kind of
exactly.
like, yeah, how it's structured, what's required, except that like this is a role that should be fulfilled somehow.
Right. Yeah, so it seems like everyone is in agreement. Maybe this is definitely a topic that we should continue to explore. Yeah, maybe I'll draft another documents of having cluster inventory and sort of start that discussion. Maybe we can try to standardize the cluster registry. What do you think about that, Laura? And
Yeah, I have one other thought. I want to know what is the overlap here, use case or problem definition between like the list of the clusters and then the list of the things in the clusters? Because I know there's been like conversations on Slack. I think there's a project called like Clusterpedia that was about having like a centralized tool set or something to, you know, get pods across everything, basically. Is that do we feel like that's in the same category, I guess?
in my opinion, I don't think so, because I think that is more of a search capability. Like you have a list of inventory, and then you wanna sort of drill down on some of the details of that inventory. But that, I think from a scaling perspective, like you can already imagine if we hold all that data on the wherever this cluster inventory
Right.
lives, it might be a little bit too much, but that's just my idea. I was hoping in the beginning of this discussion, I was really hoping we start off really small with the cluster registry, and then mainly just tie the cluster ID and maybe the cluster set together. And I even mentioned that even the status of the the cluster, I know it's useful, but maybe it's not a requirement yet. It might. I really want to focus on the requirement being having the cluster ID and cluster set, so we can sort of continue to expand, you know, that API or whatever it is we're trying to create. Does that make sense?
Yeah, I would still like to add under use cases, we can have whatever asterisk or something about the idea of then having like a tool chain on top of this that can search, can search like other resources, I guess, in other clusters, just because I know that's been talked about several times, and then we can kind of decide if that's a motivating use case for like what would actually be the client of this thing, more in that sense than like, actually solving that problem right now. But yeah, I think there's some prior art there. And I also think that that's something we could get like individual like like testimonies of like I needed this in this case, which is also is preferentially where SIG-MC wants to start from for new projects generally. So
I
yeah.
see. So having that use case of searching the resource. Got it.
So one thought is, it might be useful to document requirements in terms of the admin use cases. Like as an enterprise admin, I would like to have a single place of counting for all clusters in my enterprise, and then describe how that relates to a cluster set. Is a registry of all clusters across all cluster sets, or is it per cluster set? So if you cast it in terms of the how, I mean, I would expect this is primarily a tool for the enterprise admin. So as enterprise admin, I'd like to do this and I'd like to do this. I think that would help sell the case better. And that should cover things like, is it tied to cluster sets in some way, or is it independent of cluster sets? Or what are the other kinds of information that the admin could use with this centralized cluster registry? And then there could also be, could multiple roles with different privileges want to share access to this registry, so that, admin A only gets to see clusters in department A and admin B gets to see all clusters everywhere, things like that. Like, what is the role model and operational model for a global cluster view? So I think there's quite a bit there that as you develop the different roles and what they would like to do, then I think you can build up a case, maybe. I mean, just some thoughts.
No, that's a really good point. And just quickly touch up on the access to the cluster registry. Like, I was thinking maybe we can leverage like the cluster set here as sort of the access boundary as well. I think in Laura's KEP, she also talked a little bit about that. Any other comments before we head towards?
One quick thought is the cluster set could be a somewhat limited trust boundary, because it mandates namespace sameness and so on, right? Whereas an enterprise would have lots of clusters, not all of which have namespace sameness. So presumably a cluster registry would need to be having a larger scope than a cluster set.
Yeah, I'm very much in agreement on that. That's definitely a use case that we're interested in addressing, is having some sort of cluster registry implementation able to group and manage multiple separate cluster sets.
Right. So if you write some use cases based on that way, then I think the functionality will become more apparent and self-evident.
Okay. Thank you. That was great feedback. Okay, I don't want to take up all our time, so I'm gonna move on to our next topic, the multi-cluster control plane. So the multi-cluster control plane, obviously, as the name implies, it means having a management cluster. Now that you have, assuming you have the cluster inventory. So with the management cluster, you can use it to sort of delivery workload, perform the query that Laura was talking about, and then it's also, I guess, sort of important that the managing a cluster is similar to managing other resources in Kubernetes. And I know that in terms of design, maybe we can take a look at the existing resources and sort of scale it out to a multi-cluster ways. So a multi-cluster control plane may also have with in itself like a dedicated a pod or container with no other API support for resources such as pod or deployment in the control plane. So this might help the keeping the multi-cluster control plane lightweight. So by having that control plane lightweight, and then each control plane manage a certain set of clusters, that sort of helps with the access control that we talked about earlier as well, because each multi-cluster control plane only have a view of certain clusters, so it's almost impossible for it to see the other cluster that you don't want a certain user to see. So some of the use cases, I know that in Cluster API, it's mostly dealing with the provisioning. And even in terms of provisioning, it does sort of have the concept of, oh, this is my management cluster. So in that case, it provides the use cases to provide a Kubernetes API interface that manage multiple clusters, It contains, as we talked about, it contains the cluster registries so that we can select the clusters, search the cluster, and deliver workload, and maybe enforce some policy. And then it also provides sort of like the foundation work or the environment for all the other multi-cluster capabilities can be developed, such as the work API and as Laura mentioned, the search as well from the Clusterpedia. So that is the main goal of the multi-cluster control plane, just building on top of the cluster inventory. This is maybe a bit more high level, but does anyone have any comments on this concept?
Can you talk a little bit more about the connection point between this and how strong a connection point between this and work API? Like in here, there's a lot about like delivering workload.
Yep. So the work API, the reference implementation is written sort of in like having a centralized location where that's where your workload that you want to deliver to. So in that centralized location, it's basically can be a multi-cluster control plane. So once you apply the workload on that multi-cluster control plane, the work agent is supposed to be able to watch that workload and then pull the workload down to the spoke clusters. So I don't know if that answered your question or not, but basically it's sort of have
Okay, yeah, maybe the like work API right now, like the architecture refers to like the hub and spoke model, where the hub is where the what work you want to deliver is published. And I think you're saying that hub should be standardized into this concept of a multi-cluster control plane that maybe also serves other tooling that needs a centralized control plane.
Yep, exactly. Thank you for thank you for
Yeah,
explaining.
sorry. Yeah, I'm trying to talk it back to make sure I understand this, I guess is what I mean.
No, that was exactly it. Thank you, Laura.
Okay, yeah, I do think the interaction point with like what Cluster API does is really interesting. If I understand Cluster API well, it's more like, as you mentioned, it was more about like the creation lifecycle events and as an interface to like cloud providers, whereas this would be something more abstract, possibly, until and unless there's a standard, I guess, for how cluster sets should be created or not adapted per cloud provider. I guess that world could exist. But yeah, I definitely think that's interesting connection point, and like where, especially as regards to like where does the like charter even overlap, I guess.
Yep. But do you think the cluster registry is sort of like the prerequisite to having this this multi-cluster control plane? Or you think it's possible to implement the control plane without the cluster inventory?
Probably not as described here. I forget if this doc also has multi-cluster controllers in here. Is that also, I think that's also a topic, right? Yeah. So I think it's possible to do multi-cluster controllers without a cluster registry. I don't know if it's possible to make a multi-cluster control plane where the definition is something that knows everything about all the clusters and orchestrates their work without a cluster registry.
I'm gonna throw a really weird wrench into this.
Yeah.
Terraform as a
Uh-huh.
cluster API implementation
Uh-huh.
might be able to do something that could be a multi-cluster control plane where you apply resource to one. I'm not sure, but it might without like necessarily looking it up in a separate implementation
Mhm.
of the registry.
Yep, I think even within cluster API, there's a new API called something resource that more to deal with post cluster provisioning as well. But yeah, the cluster API, I don't know, from my understanding on project, is never about having this this complete view of the clusters, the ongoing status of the cluster and such. So I'm not sure if they. So it's more to deal with the cluster lifecycle. So I'm not sure if they're gonna continue to expand or just keep it in the specific cluster lifecycle role. Yeah. Yeah. Feel free to drop any comments and fix my spelling and grammar as well as I go. Thank you for whoever is writing that.
Yeah, I guess I don't know if I'm using this terminology right either exactly, but I feel like cluster API and like Terraform as the control plane is like that, like first provisioning, like first day experience solution. And then in like a beautiful, perfect GitOps world, we can just keep redoing day one over and over again, like Groundhog Day. But then in reality, there's like a monitoring and maintenance thing that's looking for like an active control plane, more similar to what we're discussing here.
Yep, exactly.
Yeah, I'm not sure if or how much of that might be implemented like inside the black box of Terraform Cloud.
Right.
But yeah, it's kind of a different weird angle to think about some of the stuff.
Thank you. Any other feedback before I move to the next topic in the interest of time? Because we do. Yep.
Right.
Okay.
At this moment, I mean, AKS has a product called AKS Fleet Manager, which is pretty much AKS version of multi-cluster control plane. And Kubernetes is also using a kind of like both products are using some kind of like a stripped down API version with no built-in controllers, etc., to host the core hub cluster functionalities. So I was thinking about the specific work, Adam, would it be helpful if you can provide some kind of like a reference implementation of such stripped down hub clusters, where any multi-cluster solution with a hub spoke architecture can use? Would this be helpful? Maybe some kind of reference implementation of the component for
Yep.
such.
Sorry, I cut you off there.
It's all right.
Yep,
It's all right.
I totally agree that we should have a reference implementation of this. Like the project that I work at, the Open Cluster Management also provides sort of this multi-cluster control plane. So I think I'll get to it on the next topic, the work API topic, and then we added a doc entry to the work that Nicholas and Laura has been doing, and that in that entry, I actually reference all three: the Open Cluster Management, the Kamada, and the Fleet Manager. So we will yeah, as I go through the Work API project, maybe after I'll do a quick demo of sort of how to tie the Work API, the control plane, and the inventory together with one of the implementation, just to maybe gather some feedback or notes. But yeah, I definitely agree that we should have a reference to these implementation.
And I would have the same comment as before, which is define the requirements in terms of use cases. Like as an enterprise admin, I would like to use a multi-cluster control plane to do this, right? Or like role-based role-based workflows.
Yep, that's excellent point. Yep. Okay, I'm gonna jump to any other feedback before I jump to the work API. So for the work API, I'm gonna go really quickly here because it's already a project that is established in Kubernetes SIG, and I did at least 2 presentations on it. So it's basically about having not necessarily a hub spoke architecture, but the current implementation, the reference implementation it is, but mainly about defining the work API that you want to deliver, the work API that you want to deliver the workload to different clusters. So so the use cases is you obviously deliver the workload. You want to see the status of your workload delivery, and you might want to see the status of the resources after the delivery as well. So if you're interested in this, go ahead and please visit the design doc in the repo. We have 2 YouTube video on the discussion about work API as well. And I want to do a quick demo, a really quick demo, using Open Cluster Management, and then inside it there's an implementation of the work API, sort of show that the all 3 topics that we discussed. So the cluster inventory you get with one of the APIs, so you get the managed cluster. We can see on the left side, this is sort of the multi-cluster control plane. On the right side, here there's 2 clusters that are registered to the multi-cluster control plane. So we sort of touch on this topic as well, how each namespace is dedicated to the clusters. So so now we can look at the work that we want to deliver to one of the clusters. So the namespace here is cluster 1. So we want to put the work into the cluster 1 cluster, and then the workload is simply a deployment. And then here sort of brings back some of the resource status of this deployment. And if I apply that work, oh, it seems like I already applied the work. Okay, so we can see that the work is applied on the cluster 1, and then the work is not in cluster 2 because it was only applied on the cluster 1 namespace. So if we look at the if we look at the status of the work, you can see that the resources available is being applied successfully, and they actually bring back some of the resource status, such as the ready replicas, the replicas, available replicas, etc. So that was just the quick demonstration of the reference implementation of the work API, sort of tied to the topic with the multi-cluster control plane and the cluster inventory as well.
Really quick before you go on, can you talk a little bit about like what is like open items for work API project? Like, is it that there's more vendors having more implementations? Is it like effectively this conversation here where aspects of the work API project, like the multi-cluster control plane, which is like implemented, ad hoc, I guess, in the reference implementation for work API, is something you want to pull up more as a standard? Just a quick, maybe like what's up right now. Yeah.
We want to set as an open standard for delivering work to multi-clusters. There's some enhancement proposal in the PR. We've been going back and forth on some of the items. So we'd love for the community to chime in on ideas how to standardize this work API. And our goal is to make it vendor neutral and provide neutral as well. and just having that standard API protocol, so that maybe in the future, if we have a centralized cluster inventory, we may not have a centralized multi-cluster controller, or the control plane using the work API to delivery across multiple clusters. So other projects that maybe don't have multi-cluster capability can sort of adopt either the work API or some other API to gain multi-cluster capabilities. I just gave my two cents on that, Laura. Does that answer your question?
Yeah, no, that's a good brief.
I'm gonna hand it to Mike Morris. Sorry that I took so long on the multi-cluster controller topic. Mike, do you want me to stop sharing, or you want me to just scroll down as you go?
Yeah, just keep sharing and scroll down.
Okay.
Yeah, I'll cover it briefly. So yeah, the multi-cluster controller section was intended to kind of cover a range of projects, some of which already exist, that may have some overlap or dependency on a cluster inventory or multi-cluster control plane. But essentially the kind of focus of scope is more on application functionality or networking than it is on cluster management itself. So the cluster registry inventory is useful in terms of understanding where a resource may be located or where an application may be located. But it's not really doing much more than that. It's not typically going to be concerned with any kind of workload placement or scheduling concerns. And it's not necessarily a hub and spoke. So like one kind of example of this would be a multi-cluster, let's say, cloud ingress of some sort that could be offered as a hosted cloud service. I think GCP has an example implementation of this that can route traffic to multiple different Kubernetes clusters and services within them. So that would be one example of a multi-cluster controller that is able to like route traffic to different clusters. And there's, I haven't looked closely enough, but I think right now they're within a single cluster set. I don't know that for certain. If it doesn't cover that yet, then it's certainly a point of a potential extensibility to be able to route across different cluster sets or something like that. A kind of another example I had in mind was any kind of distributed database. So having database replication for high availability or different failover redundancy models, whether that's a like writing to like multi-write or a like read replica or a whatever. So one of the examples here was CockroachDB has a example of being able to configure a database that spans multiple clusters. So I think that's another kind of like application availability use case of being able to share something or replicate availability or data between clusters, but it's focused on like kind of like application centric use case rather than being a generic implementation. Yeah, and I guess just kind of like the last point is, as addressed at the beginning, it's not necessarily constrained to being self-hosted inside a Kubernetes cluster. It could be a controller that lives externally somehow as a cloud managed service or other such implementation that is able to direct traffic into or configure resources in different clusters. And would be very happy to expand on this if folks are aware of other use cases that this could include. it's kind of like what came to mind.
Yeah, I really want to connect with the operator SDK. I know at KubeCon NA there was a talk about like multi-cluster control operators, which at least as far as I understood it from that talk and like skimming later, kind of similar to where About API is today. It's that like the concept of like an operator knowing that there are more clusters, like there is a cluster, you know, like type that like some, you know, like parts of the operator SDK are now becoming more intelligent about. But the part of like knowing what those clusters are, I think that is like the fundamental question still about like, are we is this, you know, have a dependency on something as centralized as a cluster registry, or is this about us making, you know, this piece or this like subset of it aware? But yeah, overall, just I do think like for people who are interested in this topic, and if we keep pursuing it, that connecting with what the operator SDK is doing in this space would be really fruitful.
Yeah, that definitely sounds like a connection that we should pursue.
Yeah.
I totally agree, because I took a look at I think the controller one time project. I mean, there was an item about abstracting the a certain part of the API. I think the cluster part of the API. So that was already done, and in controller one time you sort of can set up a project that, you know, you watch a resource on one cluster and then have it kind of replicated to the other clusters. So it'll be, but the usability it's a little bit difficult in my opinion. Well, it'll be really nice if it can be linked with the cluster ID and About API to simplify that. I'm not sure, Laura, if you had a look at that as well.
Yeah, only in that like general gist, but haven't like connected directly for sure.
See, maybe I'll reach out and see what the status of the ongoing multi-cluster support on these projects as well. Yeah, I'll take a TD on that. Okay, I think that wraps up for the topics that I want to discuss. I know there's still some topics, so I'm gonna stop my screen sharing.
Okay, cool. Thank you. That was awesome. And we can keep talking about these for a while and also in Slack, but I think there's some more like notes about prior art people can add in. And definitely that follow on we were just talking about for multi-cluster controllers, talk to controller runtime or get like the updates on that, maybe like do a demo or talk about it over here, get somebody to who has some insight to talk about it. And then that work API proposal and PR to take a look at as well, I think are direct action items for right now. Okay, we only have a couple minutes. Sanjeev, do you want to bring up your topic briefly, or do you want to hold it, or both?
I could frame it in a couple of minutes if that makes sense, and we can decide how much time to spend. It's actually more targeted towards other groups, but yeah, we can do that. I can do a kind of a 2-minute summary.
Mm-hmm. Cool, go for it.
Okay, let me share then. Hang on. Do you guys see this?
Yes.
So this is actually kind of a broad topic, but really just systematically looking at all aspects of multi-cluster service networking again, and looking at what more needs to be done both on foundational pieces as well as individual sub-projects. Okay. And my thought was to discuss this and had some brief discussion with the Gateway API and Gamma teams. And they had suggested to kind of build on it. So I'll be probably I'll be discussing this within the Gamma team and possibly the Gateway API team as well, and seeing how we can kind of work across these different groups. So okay, so the first thing is that this is really, again, as I think the last point that Mike was mentioning, this is about service networking across clusters as opposed to managing multi-clusters. And there's been work going on, in this SIG, things like MCS API, Gateway API, and now the Gamma stuff, and then all these different service mesh projects. And they're all in various states of completion and semi-overlap and so on. So if you look at, but I think we need to have a proper framework for multi-cluster service networking, and then based on that, re-examine these projects to see whether they need changes or additional building out. So there's the foundation between, like, what is the kind of multi-cluster network service networking model that really eventually makes sense across different scenarios. And then I feel like what's been done so far is also still somewhat piecemeal. And when projects like Gamma are coming along, which are sort of trying to combine across service mesh and gateways and multi-cluster and all that, one has to rethink as to, okay, let's properly think what is. So just to wrap up for now, this is the initiative I'm just starting to discuss within Gamma and other projects. Obviously wanted to discuss here as well. We are out of time. We can discuss it on a future call. And I'll just jump to the takeaway slide, or the next steps was essentially defining gaps and gaps on proper, a little bit more comprehensively defining multi-cluster service networking model with reference topology models, and getting into some topics like single network versus multi-network. These are things that I was covering in the slide, but we can go over it next time. And even multi-meshes, and setting that framework, and then re-examining all these subcategories like service discovery, policy, service load balancing, non-Kubernetes endpoints within that, and sort of driving this within Gateway API / Gamma in collaboration with multi-cluster. That's a very, very quick summary. There's some detail here which we could go over in another time, and I'm planning to share this within the Gamma team as well as potentially maybe the Gateway API, but probably the Gamma team. That's the quick summary. I know I mostly just teased without really giving details, but hopefully you've got the sense of where this is going.
Yeah, I mean, I think having that sort of unified how to multi-cluster service network with all the things is like something that several SIGs and working groups have like a little bit of the piece of the pie in. So like it's long-standing that it has, could use more
more resolution and precise definition and so on. I mean, and as we discuss and things like Gamma, which are again trying, so I'll just give you one out of many examples, right? When we were trying to do things with multi-cluster network policy, there was this thing about, well, what's the real multi-cluster network model to begin with, right? I mean, can we have single networks and multi-network topologies? Are they related to cluster sets, or are they across cluster sets? And there was a certain view, but then projects like Gamma are forcing us to rethink that, because when you look at a service mesh, they have different deployment models, like multi-network, for example, right? So if now you're trying to build K8s native APIs for a lot of these multi-cluster service networking models, let's precisely redefine the model again, and then re-examine each of these subcategories, like policy, like service discovery, like load balancing, within the context of that, so that we don't have these ambiguous kind of areas. I know this sounds a little loose, but there's some detail here, I promise you, which we can do in a future call.
Cool. All right. Yeah, let's table it for now because we have 15 seconds. There are a couple other notes that Mike added in under there to review, but we can also take those up next time. I also posted some quick updates and links about updates on the MCS conformance test and the SIG-MC website, but you can read those. We don't necessarily have to do readout for that right now, and more updates will come in the future as well when we have time. Thank you everybody for stopping by, and see you in 2 weeks and or on the Slack.
Thank you, Laura.
Yep.
Thank you all. Bye.
Bye.
Bye, y'all.